Hi everyone. I'm back again with this project that I just wanted to share with you guys. So this project is kind of a continuation to my previous project, which was the Fragile Store, which I shared and documented all about here on this channel and as well as on my LinkedIn. So essentially what this project was, the Fragile Story, was an AWS infrastructure which I designed and build to fail under stress. That project taught me how production systems break, but then I realized that there's a critical gap between understanding failures and actually responding to them operationally, which then led me to build this project, which is kind of an application supports engineer incident response simulator with two realistic failure scenarios, similar to the Fragile Store. With this one though has complete monitoring correlation. So I'll show you how systematic incidents response actually works and how I monitored them. Right, so we'll get into it here with first our architecture diagram of just what the project is about. And we can see we have our Flask URL shortener here with the Postgres database with Redis and the complete monitoring stack consisting of Prometheus, which pulls the matrix out of from the Flask URL, and Grafana for our dashboards, which I'm going to show later. But the difference is, you can see here we get the red arrows, which are failure injection points, with the first one being the memory pressure injections on the application layer, and the second one being the Redis Cascade failure on the cache layer. So this system was designed like this to break systematically, and then for us to monitor it and to respond to them. Alright, so over here we got our Grafana. Remember from our monitoring stack, our Grafana is connected to Prometheus, which is pulling the matrix from our application layer. So here we got a normal operation with memory usage of around 64 megabytes, response times of sub-milliseconds, around 8 milliseconds, and the database connection is stable, and our cache hit rate, which is in the other set of dashboards, will build up as we use the system. So we're going to create a few URL to establish the database, to establish the baseline pattern. Yeah, over here we're just going to create some URL and just check the basic health. We're just creating some URLs over here for this one as well as for create URLs. Yeah, Alright, going back, we can see here the 50% cache hit rate established. Half of our requests use cache data, half hit the database directly. And remember, this is baseline. It's about to disappear completely. And with the other one, here, we can see the response time increased because we created the baseline patterns. All right, so we'll start with the first scenario, which is actually this one, the memory exhaustion. We're going to inject it with that URL that we created. Alright, so let's start with the first scenario, which is the memory exhaustion simulating an application memory leak. So this is a P1 incident waiting to happen. So we're going to trigger this now by executing the post. Where is it? Memory pressure. All right. So wait, you'll see what happens. You'll see how it's slow. So it's using all the memory available, and the dashboard will show us just the result of this. All right, that's done. And just give it some time here to refresh. It should happen about now. There we go. So there. Watch how the memory just spike from 64 megabytes all the way to 5.43 gigabytes. That's 85 times increase in 10 seconds. The response times over here we can see is hitting 10 seconds, like I mentioned earlier, and that's exactly what the ASE teams will see when the memory leaks Cascade. And now we're going to see the logs, because one thing about monitoring, it just shows you that something is wrong, but then as an ASE or whoever's going to be responsible needs to troubleshoot and look at the logs and see exactly what is wrong and why is it wrong. So we're going to check to do that just now by checking the logs. Alright, so this is what the logs would show you. We can see that the logs are correlated with the timeline. You get our timestamp over here. And you see these correlation IDs over here. Correlation IDs. Yeah, the correlation IDs. Each one tracks a single request journey. So for this one falls for the past 5 minutes. And during the memory pressure, the request still completes, but the performance was degrading dramatically. Here's the memory allocation sequence in the logs. We can see it went from 24% to 43% to 60%, all the way to 88%. The system logs show exactly how the failure progresses. So the ASE teams or whoever is in charge will use the timeline to reconstruct. We use the timeline for reconstructions of the root cause analysis. And the professional communication template will be like, the P1 memory exhaustion incident happened at this time, and the impact was that the response time degraded 85% from normal baseline, and the root cause was the memory allocation spike. And the ASE teams will execute recovery procedure, and that's actually what I'm going to do now to just show you the recovery procedure. All right, so for our recovery procedure, we'll hit our endpoint over here, and we'll watch the dashboard in action. And we'll see how the memory drops instantly back to 64 megabyte baseline there, just like that. And the response times also normalized to sub-milliseconds. Yeah, over there, literally 800 milliseconds. And the complete system restoration in about 30 seconds. And that's all for the memory exhaustion scenario. We see how the total incident timeline was about 6-7 minutes from detection to resolution. The full visual evidence for stakeholder communication is also key. You need to explain with the people in charge or your higher ups, this is what happened, this is what happened, this is what happened. And so this is a incident response best practice, if I can say. So now we're going to move on to scenario 2, which is the Redis Cascade failure. All right, so for scenario 2, let's just switch our dashboards. Yeah. So for scenario 2, which is the Redis Cascade failure, this will demonstrate multi-service correlation, and it will show us that, when the cache fails, everything hits the database directly, which is a problem. So we're going to run this demonstration now. Yep. All right. So first we're going to stop. Yeah, we're going to stop the containers, the Redis containers. And we'll see the effect of that. Yeah, there you go, the Redis container stopped. There you go. You see that the cache hit drops to 0 immediately. The Redis status shows failed. There's nothing available. But watch what happens to response times. They're about to spike dramatically over here. It went from 0 all the way to 2 seconds. Yeah, that's about 16 times the degradation. Every request now bypasses the cache and hits Postgres directly. Alright, so for the recovery procedure for this scenario, we're going to restart the Redis container. I'm going to hit the endpoint over here. There, the containers have been restarted. And watch the correlation over here. The Redis status should return to healthy with response time, which is all the way over here without, yeah, there you go. The Redis status is back up to 1, and cache rebuilds gradually as requests populates to cache, as the request populates the cache again. The response time should decrease just now. So yeah, the complete multi-service recovery is over. You can see the cache availability is restored, the database pressure relieved, and the application performance is normalized again. And yeah, that's it for scenario 2. Right, so now we got 2 complete incident types: single service resource saturation versus multi-service dependency failure, both with real-time monitoring correlation with the logs as we saw. So the ASE methodology applied to both scenarios: the real-time detection via the dashboard correlation firstly, secondly the impact assessments with quantified metrics, thirdly the multi-layer investigation across logs and system states, and then fourth, the professional stakeholder communication, which is key because all this is pointless if you don't know how to communicate with stakeholders. And then finally, the systematic recovery with validation. As we saw, we went back to the normal state. So as I showed earlier, the loggings are so important because the structured logging with correlation IDs enable request tracking through failures. The memory pressure logs, as I showed earlier, show the allocation progression. And the Redis failure logs also show the cache miss patterns. So ASE will use them. It will use this data for timeline reconstruction. And yeah, the dashboard correlation also proves the cause or causation, if that's even a word. Yeah, the cause of the problems. The memory spikes correlate with the response time degradation, the cache failures correlate with the database load increases. So these visual evidence are very key for stakeholder communication. All right, as I mentioned at the beginning of the video, this project, the ASE project, correlates a lot with the project that I built earlier, which was the Fragile Store, where here is the architecture diagram for the Fragile Store. But the Fragile Store basically told me production failures pattern through controlled chaos. I knew what I was doing. The net gateway misconfiguration, the container resource exhaustion, the database connection limit, and it correlates a lot to the ASE project because as we see the architecture diagram here, we see that the ASE simulator taught me operation response methodology. So not just breaking things, but watching them break. So the detection, the investigation, the communication, and the resolution. Same system thinkings, but just different applications. And timeline for comparison for these two projects is that, the learning progression. First, understanding how systems fail, then practice response when they do. Both require systematic approach and evidence-based analysis, if I can say. And yeah, that's it basically. I feel like ASE skills aren't just about tools, about the monitoring stacks or the Prometheus and stuff like that, but they're about methodology, about system detection, structured investigation, professional communication, and validated recovery. And yeah, that's it for the ASE project. But then yeah, that's it. And I just wanted to say that this builds on the fragile store psychology. Like I said, learning through controlled failure creates deeper understanding than tutorials alone. Breaking systems teach you how they fail, and then fixing them systematically teaches you how they recover. And yeah, that's it from me. Thank you so much if you made it so far in this video. I'll keep working on more projects, and if you're exploring ASE project or something similar, I would love to hear from you. Connect with me on LinkedIn, or just leave a comment on this video, subscribe and like. And yeah, I will write a blog about this and post it. Again, everything will be documented on my LinkedIn, so if you want to read more about it, we can connect over there. And yeah, that's it for me. Thank you so much for watching this video, and thank you and take care.